All right, so now that we got the video going, so here, what we've been talking about is we're asking the question, is there a relationship? And in order to answer that, we use the formula for R being the sample value, and we're asking if we can prove something about the population, which would be rho, and that would mean that there is some relationship here. And so we use the hypothesis testing method in order to establish that, and we answer the question. If we reject the null hypothesis, which we did here, then we say there is a linear relationship. And then if R is positive, it's a positive relationship. If R would be negative, it's a negative relationship. Okay, but it's the strong positive or strong negative. Okay. So then,
we don't do the last part of the hypothesis test.
we really don't. We don't go through and do all the things with the 7 summary things. We don't need that. We just need there is or we can't prove anything. No decision. Okay. So then the next thing that we need to do is to consider what's called regression. The process of regression will answer the question, what is the formula for the relationship? Now, I want to emphasize this. I'd really like for this to sink in very strongly into your mind. The formula is describing a possible average. Now, your book is not good at this. Your textbook is bad when it comes to the statement I just made to you. The textbook seems to indicate that if you know the formula, you know what's happening. So if you say, oh, I know the oil price, so I can know the gasoline price once I know what that formula is. But that's just not true. It's just wrong when it says that. Unfortunately, they keep saying it. The formula is only describing a possible location for an average value. It's not telling you what's actually happening, because as we know, these things are just samples. I just have a few data values. I don't have all the data in the world, and so I really don't know exactly what's going on. I have a possible average, but that's all that I know. And I'm still not even necessarily sure exactly how good it is, because if you have just a few data points, maybe it was from 1983. I mean, who knows, right? So there's no way to really have complete confidence in these formulas. Unless you're talking about some kind of chemistry or something where everything does line up exactly on a straight line. Well, then it's a formula. But most of the time, what we're looking for is not that kind of a thing. And so when we say, what do I know at the end of the whole thing? All we know is very cloudy. This formula should not be trusted. Okay? We'll talk more about that later. But so let's go to our spreadsheet here. Okay? Now, I have this the information about what to do here is in your notes section where I have how to use Excel for correlation and regression. So there's instructions on how to do this, so you don't have to necessarily write everything down, okay? But I want you to see it so that you know how it works, okay? So if we go to this spreadsheet, okay, I'm going to show you, again, don't worry about writing all the steps down and having everything. Just see it and believe it to start with, okay? And then you can look at it, and if you want to stay, you can do it in the next room. Okay, so here we have oil and gasoline. I'm going to select all that data, okay? I'm going to click up here where it says Insert. And when I do that, I see under this section where it talks about charts, there's a little thing where it has a bunch of scattered points right here. That's what I want. I'm going to hit that, and it says scatter. That's what I want, scatter plot. Click on that, scatter plot. Okay? It just graphed it for me. Okay, which is nice. I'm going to make the things a bit larger so you can see them a bit better here. We'll go 14 here. Okay? So, does this look like a positive relationship? The higher the oil price, the higher the gasoline price. Yeah, kind of. It's cloudy, but yeah. So what I can do is I can click on these dots right here. Notice they all became little X's. And then I right click on them. And I go down here where it says Add Trend Line. And it just drew a straight line. Okay? That straight line is based on a formula which is in your textbook, and it's really complicated, which we're not going to do. And then if we go down here where it says Display Equation on Chart, we click on that, it displays the equation on the chart. So there it is. Okay? So this is where all of that experience that you had in algebra before you walked into the room here is going to be maybe helpful. Okay? So, what is this thing? This is called the best fit line. What is the formula for a best fit line? Well, unfortunately, there's more than one version. Correlation regression. Regression. Here we go. What is that best fit line? Well, after we get through the whole thing, the textbook says y prime is equal to a plus bx. This is not what your algebra book would tell you. Does anybody know what the algebra book says for the equation of a line? Mx plus b. Okay, there we go. I'm like that all the time. How did I know what that is? Okay. These are not the same. The letter B does not mean the same thing. They're different. Statistics has hundreds and maybe 150 years of tradition to say that this is how you write the equation of a line. Algebra has a lot more years of tradition, but you're not in algebra class, you're in statistics class, okay? So, which one do you have to use? The one that works, all right? Everyone works, all right? If it works, good. But that means you need to understand what these things are telling you. There are two things happening here with a line. First one is the slope, and the second one is the intercept. The slope tells you the direction of the line. Intercept is a way to tell you the location. How can you get from here to La Crescent? Go that way, right? But if you were in Rochester and I would say, how do you get to La Crescent? You'd have to go a different direction. So how do you know where to get from one place to another? You have to know your location and you have to know the direction if you want to get somewhere. So that's what a line gives you. You have to know what direction you're going and you have to know where you're starting from or something. Okay? So the slope or the direction is the number in front of x. So when you see a formula, the number that's in front of x is the slope. Whether that's in the first part of the formula or the second part of the formula, doesn't matter. Whatever number is in front of x is the slope. What's the intercept? It's the other number. So there are two numbers in a formula. The one that's in front of x is the slope. The other number is the intercept. So let's go back to our example. Here is the formula for the relationship between gas and oil. If we say y is equal to 0.0237x plus 1.237, this number is the slope, this number is the intercept. Now, as it turns out, most people have an idea of what the slope means. Can somebody tell me what is the meaning of slope in a line?
That'd be the angle that
It's related to the angle that it's at, yeah. It's called rise over run. It means that if you run a certain amount, you're going to rise a certain amount, right? So if this slope were to be a big number, it would be a very steep line. It would rise a lot. If it's a low number like this, then it doesn't rise very much. Notice in our example, this goes from like 40 to 80. This went from 2 1/4 to 3 1/4. So it went a long way this way from 40 to 80, and it only went a little bit that way. So the rise is small compared to the run. So that means this is a small number. So if the slope is a small number, then the y only goes up a little bit. If the slope is a big number, the y is going to go up very fast. Okay? What if this had been a negative number? Well, that would mean it would be going down. That would be a negative relationship. So the big deal here is whether the slope is positive or negative. That tells you the direction of the relationship. If it's positive, then the more of an increase in x, there's an increase in y. If it's negative, increase in x, decrease in y. We already saw that, we already talked about it, but this is also true. Now the trouble comes in, most people don't understand the meaning of the word intercept. What is the meaning of the intercept of a line? Anybody want to take a guess?
Where the line meets the data.
No, not quite. Somebody else have an idea?
For X and Y meet?
Not really, but kind of. Okay? The intercept would be if I were to extend this line all the way down, where would it cross when x is equal to 0? Okay? So the intercept, when we talk about it's the location of the line, it's telling me where the line is located. But specifically, the intercept tells me what is the y value when x equals 0. Now the problem with that is that number by itself is often not included in our data set. Okay? So let me just make sure I'm telling you the right thing here. Okay. Many times, this doesn't make sense. Again, what we're really wanting to do is we want to understand things that can actually be measured. We're talking about asking people 2 questions or looking at 2 different measurements that we're making. We want to look at real things that can actually be measured. Is it possible the price of oil is ever going to go down to 0? No. They're never going to give that stuff away. So it doesn't make any sense for us to use 0 in this formula. If I put 0 into the formula and I come up with, oh, gasoline is $1.24, that's just not going to happen. So it doesn't make any sense. But that number needs to be there in order for us to have the right location of the line. So it's in the formula, but that number by itself doesn't actually work. Okay. However, we can do predictions. If x was equal to 50, what is y prime? If I put in for my x value the number 50, I want to know what would happen in the formula when I do that. Okay, so what's the process? Putting something into a formula. This is not really a complicated formula. Hopefully you understand that. I'm going to take the number 50 and I'm going to put it into the right side of that formula, which means I'm going to take the slope, multiply it by 50, and then add that number. So I want you to get your calculator out and I want you to see what happens when you do that.
You said one more time?
Sure, I'm going to take the number 50, I'm going to multiply it by the slope, and then add the intercept.
So we're using the algebra formula.
Yeah, because that's the one that Excel gave us, so we'll use it. All right, Eric, what do you got?
2.422.
2.422? Okay. Amber, is that what you did?
Mhm.
All right, that must be right. Now, does that make sense? If I look at my graph, 50 is about right here. 2.4 is about right there. Yep. That works. Now, your textbook will tell you that that's going to be the price of gasoline. I'm telling you it's not, okay? If you know the price of oil, you don't know the price of gasoline. There's too many other things going on. This is not an actual straight line. This is a collection of dots. Where are you going to land if oil happens to be $50 a barrel? You could be, who knows where. So this number, this 2.422, is it useful? Maybe, but it's actually not telling you what's happening. Even though the textbook says it doesn't, but it doesn't. It's a prediction. It's based on a sample, which we know is not going to be correct. And obviously, when we say, is it a straight line? No, it's a collection of dots. So it doesn't work because it's not an exact formula, and it doesn't work because it's a sample. Next time we do these calculations, these numbers will all be different. What's going to have to happen eventually is that we're going to be doing confidence intervals for this, not just coming up with numbers. We need confidence intervals. But that's not right now. Right now, when on the homework it says, put in this number and find out what you get, then that's what you do. Put in the number, find out what you get. Okay. Now, there's this concept that's involved when we work with data and we work with these predictions. 2 words: interpolation and extrapolation. And this is where all that Latin comes in handy, okay? So yeah, I don't know. People do study it, right? Every once in a while. Latin. Where does the interstate go? It goes between the states. What if you have your internal organs? They're on the inside, okay? What if you have intercollegiate athletics? That's between different colleges, right? So interpolation is looking inside your data set. So if I go here and I say that the oil price is 50, then that's okay because that's inside my data set. I can do a prediction using 50. It's not going to be accurate, but it's going to give me some idea of what that number is. Where do you find an extraterrestrial? Outside of the Earth. Where do extracurricular activities happen? Not in the curriculum. If something's external to yourself, it's outside of you. So extrapolation is where you look outside of the data set. And this, in a word, is bad. Okay? If you say, I want to predict the relationship of oil prices and gas prices, there's no way that you should use the number 40 or the number 90 or 100 because those are not in your data set. You know that this is some kind of a straight line, but you don't know what happens outside of your data set. And we've already proven, if you use the number 0 out here, that's just crazy. So any number that you're trying to predict, if it's not in your data set, it's not okay for you to use it. Interpolation is okay, even though it's not accurate. Extrapolation is just bad. Let me give you an example. Housing prices. Do real estate values always go up? No, they don't. But they went up for maybe, I don't know, certain locations, maybe 20 years or so. And people said, hey, you should invest in real estate. If you invest in real estate, then it's a good investment. And then the federal government said, if we get people to buy houses, they'll be more likely to have good neighborhoods. So we're going to have a government program to help people buy houses. And then a bunch of other people said, if we get somebody to buy a house, then we can sell that mortgage to another company, and then we don't have to worry about it. So the more houses we sell, the more money we make. So let's sell a bunch of houses. And so then a lot of people did that, and housing prices just went up and up and up. The stock market went up. Oil and gasoline prices went up. Everything went up until somebody stopped paying their mortgage. And then a lot of people stopped paying their mortgages. And then a lot of people had foreclosed houses that they couldn't sell. And then the entire country had tons of houses that couldn't sell because people didn't have money to buy them. And then we had what's called the Great Recession. And we had oil or gas prices went from $4.50 down to about $1.60 in 2 months because all of a sudden people had to pay for these houses they didn't have any money for, and so they had to sell all of their shares in the oil companies and all that stuff. So it's a big problem. The line, if you say here's time and here's real estate, it had been going up and up and up and up. And people said, well, it's just going to keep going. But it didn't. It went down really fast. So just because you see something that's going a certain direction for whatever reason, doesn't mean it's always going to be there. And just because you have something that's a straight line on a section of a graph does not mean it's going to keep going down. Right? So I wanted to show you one other thing before we go into the next room. And that is incarceration, urban incarceration rates. Yeah, here we are. So this is a thing where we look at, for white people, if there's higher poverty rate, there's a higher prison admission rate. Notice that this is a very much of a cloud, right? This is not a straight line, pretty obvious. But if you have a really low poverty rate in the white population, you've got a really low prison rate. But if you go up here, and they do scatter out quite a bit, but if you have a higher poverty rate, then this group is higher than this group down. And they have their R value is about 0.7. So it's pretty good, pretty strong. Okay. But what happens when you look at the black prison admission rate by the black percent of poor? It's not that way. So you don't see a clear trend that if you have higher rates of poverty in a black county, then you have higher rates of prison admission. So what you're saying when you do this is that you're saying poverty is a clear correlation with people going to jail if they're white. But if they're black, it's not a clear relationship. So there's something else going on. I don't know what it is, but clearly there's something else going on. Now, smart people would be able to figure out maybe what's going on. But just so that you see, this is how it's done. This is how the research happens. People look at different variables and they say, are they related? Are they connected or are they not? And, you know, we could go and criticize this essay for whatever reason, but we can't really argue with the graphs, right? It's pretty clear that poverty and crime are associated clearly in the white population, but not so much in the black population. So there's reasons. We don't know. All right. So what's going to happen right now is that we're going to go, those of you that want to are going to go in the other room and you can pull up your homework and you can actually work on it there with the computer commands so that you can make that happen, right? So we'll do that right now.